Hi, today we are going to discuss about HashMap internal working in Java. So, immediately, let's get started. This is our today's agenda, HashMap internal working. We will go through all these concepts one by one. So, first we'll see what is HashMap. HashMap is one of the collection which will store the data in a key and value manner. It stores the data as a node which have key and value. We will discuss what is a node in the later of this session. When we are accessing the data, HashMap is very fast compared to other collections. Why? Because it uses hashing. And average put and get is 1. So before jumping into it, we should know what are the main variables. Here we can see which is having number of nodes. If you see here, node of array, which will be called as table in our X map, these are all nodes into the array. The underlying array of buckets, each holding a linked list of nodes. We can see here the linked list of nodes, which is stored by node array. Each bucket will be stored linked list. So, size, the total number of key value pairs currently stored in the map. If you can see here a node array of table which is having three key value pairs. This bucket which is holding two nodes, this bucket which will be storing one node. We have completely three nodes, each node having key and value pair. The capacity, the number of buckets in the table array. We can say these are the number of buckets which is available in the table. We can say the capacity equal to 16. This is the default capacity. If you want, you can increase and decrease by your own. We can create a hash map with your own capacity and load factor to measure how full the map is allowed to get before resizing. The load factor you can say after 75% of the table is filled, we can do resizing. So the default load factor will be 0.75. That means 75% of the table is filled. It will be resized. We will discuss about resize later of the session. And threshold, the limit at which map will be resized. The threshold, we can say, as we discussed already, we have a capacity of 16 and load factor will be 0.75. The 75% of the table will be 12. So, as we see in the diagram here, we can see the default initial capacity, which is one left shift of 4, that is 16. The maximum capacity, that is one left shift of 30. The default load factor, which we discussed already in the diagram, that is 0.75, which is a float value. And the Treeify threshold, untreeify threshold, min treeify threshold, all will be discussed later of this session in detail. So the Treeify threshold default size will be 8, untreeify will be 6, and minimum treeify capacity will be 64. And this is the node which we'll be calling about. This is a static class which is sitting inside HashMap, and it has hash key value and next. So in HashMap we used to see these terminologies, that is table, buckets and nodes. Node is nothing but a node of array which is having list of nodes. Each index will be holding a bucket. Here, bucket is nothing but a linked list or tree which will be generated based on the collision. So, listen carefully. This is called table which is having 16 nodes. The name as table. Each index we will call it as a bucket. So, bucket will be turned to a linked list or tree if it is a collision happens. A node which holds, as we discussed already, key, value, hash, and next pointer. These are the terminologies we should know before jumping into the hash map. This table has a fixed size of 60? No. This is our choice. We can increase or decrease as we already discussed. And HashMap is a not a thread safe and order is not guaranteed. Why it is not a thread safe or not order is not guaranteed? If we have two threads which is operating same node, the race condition or data corruption will happen. Multiple threads modifying the map simultaneously can lead race condition. Definitely, it will lead the race condition. Risk includes infinite loop during resizing, lost updates, or corrupted internal structure. No internal synchronization mechanism, and order is not guaranteed. Suppose if we insert the data into the hash map, we don't know what index will be generated and where data will be stored. It can be stored at index 1 or index 5 or index 8, bucket 2, bucket 5, bucket 8, bucket 8. Any bucket, the key and value pair will be stored. So, when we are talking about order of the hash map, I have added 20 elements to the map. So, when I'm printing the elements, it will not be in the same order. See, first the first value will be created, then second 0, 5, 6, like that. The order is not in preserve, so we cannot guarantee about this order. So if you want to make guarantee about this order, we should go with linked hash map. So it will be in proper order. What are the order we have given? Okay, now we'll go with hash map. So see here, what I am doing, I'll be added elements to the map. Now I will be iterating the map. While I'm iterating the map, I'm putting the elements. Map dot put. So what I'm doing while iterating, because I'm operating on the bucket, the same time I'm trying to add new element to the bucket. So hash map will not allow that. See here, we will going to get concurrent modification exception. How we can avoid that? So by using concurrent hash map. See here, nothing will be happen. So in this case, we can use concurrent hash map. These things we can discuss upcoming videos. And also when using multi-thread, how hash map and concurrent hash map will work. That also we can discuss later. So hash map initialization. It is lazy allocation. How it is lazy allocation? Whenever we create a new hash map with initial capacity or with default capacity, if you don't pass initial capacity here, it will be default capacity. So whenever we create a hash map, the load factor will be assigned with 0.75, as we already discussed. The threshold will be initial capacity into 0.75. This is also we discussed. Here, the main point is the table will be null. Bucket array is not allocated. So we can see here the table is empty here. The bucket array is unallocated. Bucket array is only allocated upon the first put operation. Here, the employee object, what we are using for key and string is a value for this hash map. So upon the first put operation, the lazy allocation will be happen. We see here map is created and we are setting key as a employee and string as a value. So the bucket is created here with a size of 16. So why it is created with a size of 16? We have not passed any capacity here. So default capacity will be 16. The node array will be created with the capacity of 16. Whenever the map is created, the lazy allocation of bucket array will be happen. Apart from that, the hash code will be created for the key. This should be added into this bucket. So how this will be added to the bucket? First, for the key, whatever the key we have passed, suppose employee here, the default hash code will be created. So we have not created any custom hash code method here. So the default object hash code method will be called, and the hash code will be generated as per the hash code method. It is not deterministic. We will check this one as well. Here, the index will be calculated. It is calculated as a 7. So, index 7 will be bucket 8 here. So, 0 to 8. This will be called as a seventh index. Here, the node object will be created, not employee object or value. Both employee object and value. Set it into the node. That node will be added into this bucket. As we discussed already, always node will be added to that bucket. That means this index reference to this bucket. And this warning, suppose I have created a hash code based on the employee object. Next time, when we are getting that object, we are creating a new object with one two three. Again, it will create a new hash code. Why? Because hash code method we are not created. So the hash code for the every new employee object, new hash code will be created. That is the reason it is telling here without hash code equals, you might never find this entry again. A subsequent get definitely, we will likely produce a different hash code. So to see in practical, I have a hash map which is created, but I have not added any element to this hash map. So if I run this, see the table length will be 0. So we cannot directly call table field here. We have to use reflection just for demo purpose. I have written the code. Don't consider this code. Just consider we have written only hash map. So suppose I have not given any capacity. If I give capacity 4, see initial capacity is created. Still the value will be 0. When we add element to the map, the table length will be decided. The table will be created at the time. Now, I have said that new employee object here. If I run now, you can see here table length will be 4 and map size will be 1. And when we are reading here in the get method, we have created a new employee object with the same ID which we have passed here. Still, we are getting a null. Why? Because it both have different hash codes. To keep maintain same hash code, what we have to do that we'll discuss later of this video. I don't pass any capacity here, and if I run this, the default capacity will be 16. As we discussed already, the table length will be created with the 16. And how many ways we can create a hash map? See, we can create a hash map without any, with zero arguments constructor, and also with map as a one argument. That one more is with initial capacity, which we already created first time. So initial capacity and load factor also we can pass to the hash map. Load factor also we can decide it cannot be always 0.75. We can change it as per our requirement or as per our need. So now we will see the importance of hash code and equals method. Equals method. Why? Because we have not used any custom hash code method here. So every time new hash code will be created for the same object. Suppose if I give same object with 1, 2, 3 and John, it should get the data, but we are getting null. That is wrong. So next we will go with the complete workflow of hash code and equals. Suppose let's consider we have already some elements here, key 1, key 2, key 3, all these nodes which is already we have in the hash map table. So in the same index, we have all three elements. Why? Because it has collision because same hash code will be created. Now I send key K. K I send. So for K, it generated hash code. The hash value will be created based on the hash code. Next, it will calculate the index. Now, for this K, again, it's found same index I. So it comes here. Now, it is it needs to compare whether this object with the K, which is already available or not. Why? Because even though if it is available here, if I create a new object with the K, then it is a duplicate. So what it will do? It will iterate the bucket and compare using K dot equals method. So the dot equals method will be called, which is there in the object, or else we can create our own equals method. We will see how we can do that in the later of this video. So I am going with equals method. So I send k here. So I am be checking k equals to k2. So this key equals to this key. If it is match, so match is found. Both keys are same. So as per this existing new employee 123 John. So again I send new employee 123 John. So it will be equal by the equals method. So we are not calling object equals method. We have created a new equals method with 123 and John. We will be setting if both are equal return true, that we will see later of this video. Now k equals to k2. Yeah, yes, the match is found. So if it is found, what it has to do? It should be updated. What value it should be updated? What are the value we have sent with this key that will be updated here? So next, what it will do? It will go and compare with K3. Suppose if does not match here, what it has to do? It go and compare with K equals to K3. Whether this match is find or not. If don't found a collision, what will happen? It will append the new node. See here, it is appended new node with KB. The hash code is it will be H1 here. Why? Because same hash code will be created. If you see practical, so I have a hash map and I have created without hash code one object. Now I'll go with employee object, which is having hash code equals method. Why I want to give equals and hash code method to operate these two methods from my side as a custom, so that whatever the value I want, I can return. So I change everything to employee just. Now I have a hash code. This hash code is returning one. So every time same hash code will be returning and equals. So first time I'll go with return false. So every time new object send, it will create as a new object. Now if I pass, so we can say the size of the map will be 3. Why? Because these three are having different based on equals method. I'm returning false here, even though the hash code will be 1. If I run this, so I'll get map size as 3. Even though these two are same, I'll be returning 3. The map will be having size of 3. So it is created as a new node. If I go here equals method, so Here, we are calling equals method. We are creating a custom code here. Whenever these IDs are same, return true, or else return false. So now we can say how many objects will be created. Only two. Two, sorry, how many elements will be added to the map? Only two. The third element will be updated with the first element. So this third element will be updated with first element. So we can see only B and C. So size will be 2. If I want to print map, see here, C and B. Only two elements are there. Now we can see hash code and equals method in detail. The hash code, which is decider of the hash code will be decider of the bucket index. Here, whenever we send a key here will be employee object. In our case, it will be generated a hash code. Then hash value will be generated based on the index. It will be added to this bucket. So it decides the bucket index and equals method will do comparison between keys. If keys are same or different, this comparison will be done by equals method. Both are definitely required to correct the hash map behavior. So keep in mind hash code equals will plays a major role. Equals and hash code contract. Suppose if equals hash code must be the same. In this case, A equals to B and that hash code must be true. If hash code is same, objects may not be equal. Suppose, for example, let's consider I have table here. So here A equal to 1, B equal to 2, C equal to 3, D equal to 4, E equal to 5. So now I want to send the object which is C equal to 7. These objects are same by equals method. These two keys are same. Now it has a hash code of 1, 2, 3, and this has a hash code of 1 to 7. What will happen? Instead of updating this C value here, it will go and create a new node C equal to 7. That is completely wrong. If objects are same by equals method, the hash code should be same. It should be 1, 2, 3. So that is what we are discussing here. If equals hash code must be the same. As we see here, if equals C equal to C, then hash code will be same. It should not be different. And one more case, if hash codes are same, objects may not be equal. We'll see D equal to 7, 9, not D. We'll take something which is not there. Suppose F equal to 9. So this object are this object and this object are different. Suppose it has same hash code, no problem. It will generate here. Suppose it has different hash code, what will happen? It will add here. So no problem. If both hash codes are same or different, in the case of objects are different, we don't have any issues. Now, hash map resizing. As we discussed, whenever I have a table, this table having 16 records, consider capacity is 16, load factor is 0.75, threshold is 12. These things we already discussed. Now, if it is load factor is 0.75, the threshold will be 12. So, this is the threshold. The size is 12. adding 12th element. So I have added 12th element. What should be done? It should increase the table size. If you see here, adding 13th element. So okay, adding 12th element, that is fine. Adding 13th element, it should increase the bucket size. Now from 16 to it goes to 32. That is 2 power n. Always the value will be 2 power n. As we see in the beginning, that is always we see here power of 2. The default initial capacity must be power of 2, and always whatever the capacity also will be power of 2. We will discuss all these things. Now this is power of 2, 2 to the power of 4. The next value will be 2 to the power of 5. So the size will be 32. Now the new capacity becomes 32. The load factor will remain the same. The threshold will be calculated based on the new capacity, that is 24. And one more important point. Here the table is created based on the hash and index. Whenever the resize happen, again all existing elements will be rehashed with a formula, and it moved to new buckets. So every time the capacity will increase, all the data which were added into these buckets will be rehashed, and it will go to different index. It is same, not it's not same as previous bucket. On sometimes it will be same, but sometimes it will not be same. We cannot guarantee that. So if you want to see example, so first we'll see what is this default initial capacity of is power of 2. We go here. So I have given default capacity will be 2. So whenever I add the element, then only we can see that. That is the reason I'm saying whenever I add the element, then only the table we can see. That is the reason I have added some elements into the map. Now default capacity is 2. When I run this, default capacity is 2. When I give 23, which is not power of 2, what will happen? It will always take next power of 2. That means 32. 32, as we discussed. So that is what initial capacity. So map size is 11. Fine. The capacity will be 60. So if you want to see table data, now hash map collisions. So whenever I return same hash code, as we already discussed, if you return same hash code, it will be added to the it will be added into the same index 10. As per this, suppose it is calculated as a index 10, and here the new employee objects 101, 2, 3 have added. It will goes to the same index. Why? Because it is generating the same hash code. With this hash code, it will generate the index as 10. For every object, it will be same index. So it will go sit it into the same bucket, index 10, as a linked list. So whenever there is a collision, this is called collision. Whenever we get the same hash code, we can call this one as a collision. It will create as a linked list all the records with the same bucket index due to the collision, all chained together in a linked list. I have a table here with the 16 and index 10. As you see here, index 10, I'll be keep adding the elements. So I have added 8 elements. That's absolutely fine. Now when I add the ninth element, what will happen? We go here, the hash map. We see what is the Treeify threshold is 18. If I go here, what is the Treeify threshold is 8. I am adding ninth element. That means the Treeify bin method will be called called inside of the hash map. So the linked list size reaches. It will be called Treeify bin. What this Treeify bin method will be called resize. So what it will do whenever we add the element, it should go to tree. That's what from Java 8 onwards. Whenever threshold reaches, Treeify threshold reaches here, not here. Whenever here threshold reaches, the bucket size will be increased. Whenever here in this linked list threshold will be reached, this is called Treeify threshold. Whenever we have reached this one, it should go to tree. That's how it will be. That's what they call it as a Treeify threshold. But still, if you see here, it is not converting to tree. It is still linked list. Why? How it become a still linked list? There is a one more condition. Min tree height capacity. The smallest table capacity which bins may be tree height. Otherwise, the table is resized to many nodes in the bin. Should be at least 4 into 3 5 threshold to avoid the conflicts between resizing and treeification threshold. We'll see. The min try key the min 3 5 capacity is telling 64. That means here what is the bucket table size? 16. And what is the tree 5 threshold? 8. But as per this, we need 64. Until unless the table is 64, it will not convert to tree. If we go here, put value method, here is the bin count is greater than or equal to tree 5 threshold. The bin count, if you see here, is 8. Now added ninth element. So bin count is greater than or equal to tree 5 threshold. Then it will call tree 5 bin. If you go to tree 5 bin, if you go to tree 5 bin, this will call resize. Here it is clearly telling table dot length is lesser than min try capacity. So this is the condition. Be careful. Whenever table length is lesser than min try capacity, then it will go for resize. You see here, my table length is 16. My tree 5 capacity, min tree 5 capacity will be 64 as we already seen. Min tree 5 capacity will be 64. So table length will be 60. What it will do? It should call resize method. The resize, what it will do? The old capacity left shift of 1 means it should be increased to double. The new capacity will become 32. That's what we are seeing here. The table size of 16 will become table size of 32. The ninth element will be added here. So what will happen if I add 10th element here? So what will happen if I add 10th element here? Again, it will check the condition 10 is greater than 8. Again, it will call 35 bin. Then again, it will go to resize. Then it will become 64. Until it reaches 64, it will keep call these things. Once it is reaches 64, what will happen? It should convert to tree as per the condition. We already met this condition. It is greater than. So replacement the tree node. Instead of node, now this will become a tree node. That's what. The linked list bucket will be convert to red black tree. When if bucket nodes become large, convert to red black tree. This condition should satisfy. Tree 5 when nodes is greater than or equal to 8 and table size is greater than or equal to 64. So what is the benefit of tree map? Definitely search improves to O of log n. And tree 5 happens when nodes reduce. That also we will discuss. See here, adding 11th element. When adding 10th element will become 64. Adding 11th element, it will convert to tree. And tree 5. Suppose I have a tree. Now I am removing some elements from the tree. If bucket nodes reduce to 6. Now suppose I have a 11 elements here. When the bucket nodes, sorry, when this tree will become lesser than 6 or equal to, lesser than or equal to 6, convert back to linked list. Optimize the memory performance for small buckets. It has given like this. So this untrify, you see here, this is what in the beginning of the video I told you we can discuss. This is about this one. Untrify threshold will be 6. That's what we are talking about here. Is less than or equal to equal. If lesser than or equal to 6, convert back to linked list. That's what explaining here. That's what I'm explaining here. So few nodes I'll be deleting and it is converting back to linked list. Current size is 8 and removing two elements it will become linked list. What will happen? Instead of adding a ninth element here, I will give a new hash code. Instead of adding into the index 1, it will add at index 2. Why? Because I have given new hash code. It will add it into the bucket 2. The size will be 8 and here the new size will be added. It no need to convert to tree. Why? Because this linked list size is not yet become greater than or equal to 8. So Treeify threshold is not yet met. No need to call Treeify bin. It will be added to the index 2. No change in the capacity. Capacity no need to change. Why? Because it not yet met the Treeify threshold. It will no need to call the Treeify bin. It won't resize. The size will be 16. If it goes more than 8, then whenever, just a simple note, whenever the linked list size in the same bucket will be more than tree 5 threshold, tree 5 threshold, then only this will be increased up to 64, then converts to red black tree. Null key handling. Suppose only one null will be only one null will be allowed. Maximum one null key allowed. It will be added into the bucket 0. It always sit into the bucket 0. See, null keys always goes to bucket 0. Reinserting null key, definitely it will update the value. Get null case. If key is not present, that time we will get a null. If value is null also, we'll get null. So the best practice is keep contains key method. Yes, the get flow. If key is null, go to bucket 0 and return the value. If not, it generate the hash function, go to table and get the value. Here we're searching in the bucket using hash and equals as well. That's what we discussed in the earlier. If it has collisions, definitely it goes to equals method. But because this is the bucket and this is linked list, consider. So if it is a tree, it will go like this. Linked list to tree search. and linked list traversal. This traversal will be like this, and presearch will be like this. Presearch will be like this.